Welcome to this explainer. Okay, so today we're going to dive into a completely wild, high-stakes scenario. I want you to imagine just for a second that the fundamental force holding our entire world together just suddenly switches off. Not forever, just for a highly specific, kind of agonizing window of time. What if Earth literally lost gravity for exactly 5 seconds? I know it sounds like the plot of some crazy blockbuster movie, right? But we're going to break down exactly what that would look like using actual real-world physics. It's a ticking clock scenario that's absolutely going to change how you view the world around you.
Picture this. You're just casually walking down the street on a totally normal Tuesday. You take a step, and instead of your foot hitting the pavement, you just keep going up. You start floating. And actually, it's not just you. You look around, and cars are literally lifting off the ground. The water from a nearby fountain, it's rising into the air in these weird floating blobs. People, stray dogs, bicycles, absolutely everything that isn't bolted down just begins to drift upward into the sky. It would be instant, utter chaos. Now, before we get too carried away, it's super important to note that scientists do not expect this to ever actually happen. Obviously, this is a completely fictional scenario. But by applying real-world physics to this giant what-if, we can unpack the exact physical chaos of this brief window right before gravity violently snaps back into place. Now, 5 seconds might sound like almost nothing, right? I mean, you can hold your breath for way longer than that. But as we're going to see, when you remove the anchor of our planet for even a handful of seconds, the consequences are honestly mind-blowing. All right, let's really get into this. Look, we don't need a textbook definition to know gravity is basically the glue of our universe. But we honestly tend to forget the sheer scale of what it's actively anchoring right this very second. It's not just keeping you sitting there in your chair, it's literally pinning down trillions of gallons of ocean water. It's holding a massive atmospheric pressure system right against the crust and, oh yeah, tethering the moon in its orbit. Without that anchor, the whole rulebook of reality is just completely tossed out the window. So let's start the clock. Boom! The very first second after gravity disappears, the change is instantaneous. Total weightlessness hits. Every single person on Earth suddenly feels extremely confused and, naturally, totally terrified. Because you aren't being pulled down anymore, you just become completely weightless. Any object that isn't tightly secured immediately begins moving away from the ground. We're talking furniture, tools, unbelted drivers in cars, actually even the cars themselves just lifting off. You'd feel totally disoriented as your brain desperately tries to process a complete and total lack of up and down. And as that clock ticks through seconds 2, 3, and 4, the chaos scales up exponentially. We transition really rapidly from just feeling weightless to this massive shifting of Earth's natural resources, to heavy objects drifting higher and higher. Every single passing second just compounds the danger, setting the stage for a seriously catastrophic climax when the clock finally strikes 5. But hey, the immediate danger isn't just flying cars. By the second and third seconds, we have to look at the water. I mean, what happens to the oceans, the rivers, or even just the swimming pool in your backyard? Well, water naturally stays on the ground because gravity pulls it there. Without that pull, water would just stop resting on the surface and begin moving away from it. Massive sheets of ocean water would start hovering upward. Now, because 5 seconds is a super short amount of time, the water wouldn't just, disappear into space. It would just lift into these chaotic, giant floating waves completely suspended in the air. Which brings us to a pretty important point, the air we breathe. A really common fear is that without gravity, all our oxygen would just immediately rush out into the vacuum of space, right? Well, Earth's atmosphere normally stays wrapped around the planet thanks to gravity. But 5 seconds is simply not long enough for the atmosphere to vanish entirely. The air would absolutely start to expand, and people might notice some weird temporary effects, like, pressure changes popping your ears, but you wouldn't suffocate. The breathable air isn't going to just vanish in 5 seconds. So, since we still have our atmosphere, what does this actually mean for people already up in the sky? You might assume airplanes would instantly plummet, but remember, they rely on aerodynamic lift, not just gravity. As they move forward, the air pressure under the wings keeps them airborne. So believe it or not, during this 5-second window, airplanes would actually just keep flying. They wouldn't simply drop out of the sky. The real danger for an airplane isn't the sudden loss of gravity. It's what happens just a few seconds later. And we definitely can't forget about our celestial neighbors. What about the moon or the thousands of artificial satellites orbiting us right now? Would they instantly just fly away into deep space? The short answer is no. On a cosmic scale, 5 seconds is literally a blink of an eye. Orbital changes require a lot of time, So while their paths would shift ever so slightly without Earth's pull anchoring them down, 5 seconds just isn't enough time for the moon to abandon us entirely. Our cosmic neighborhood would remain largely intact. And then the clock hits 5. The 5 seconds are up. That brief, confusing, floaty dream is totally over. And honestly, this moment right here is the absolute most dramatic, terrifying part of the entire scenario. Because gravity doesn't just slowly wake back up, it instantly snaps back on with its full, completely unforgiving force. The real disaster isn't the loss of gravity, it's the violent return. Everything that drifted upward or sideways over the last 5 seconds is suddenly yanked back toward the center of the Earth, and hard. People who drifted into the air plummet back down. Cars and loose furniture come crashing straight into the pavement. And remember those massive sheets of ocean and river water? They slam back down, flooding cities and coastlines instantly. Buildings and infrastructure that were perfectly fine during the floating phase are now just bombarded and heavily damaged by thousands of heavy falling objects. When it comes to human survival, the stark reality is basically this. You wouldn't instantly die just because gravity disappeared. The float itself is mostly harmless, save for being incredibly disorienting. The irony here is that the total loss of gravity wouldn't kill you. The return to normal would. Anyone who happened to drift near a high place, anyone caught inside a floating vehicle, or honestly, anyone just standing underneath heavy objects that drifted up is at extreme risk. That violent fallback to reality is incredibly dangerous.
So the crucial point here is understanding the true scale of this event. Would Earth survive? Yes. The damage from objects crashing back down would be severe, for sure. It would cause massive destruction in cities, and emergency services would be totally overwhelmed. But these effects are just temporary. This is wildly different from gravity disappearing permanently. If gravity vanished forever, our atmosphere would eventually bleed out into space, the oceans would straight up boil away, and the planet itself would likely tear apart. A 5-second loss is a massive, highly destructive hiccup, but it's not the absolute end of the world.
5 seconds might sound like almost nothing, but if Earth's anchor disappeared for just that brief, tiny window, our world would become instantly unrecognizable. The ultimate paradox of this whole thing is that the most dangerous moment wouldn't be when gravity vanishes, but when it finally comes back. So take a look around you right now. What do you think would happen in your exact city if gravity switched off for the next 5 seconds? Thanks for exploring this explainer with us.